To make an announcement about the Bitcoin direction forecast. I'm Choi Min-gi, a senior majoring in computer science. First, let me tell you about the project goal. The goal of the project is to interpret data from the Bitcoin 15-minute chart to predict whether it will rise, fall, or lateral move in the short term. Let me explain why I choose this topic. Typically, when predicting Bitcoin prices on platforms like YouTube or blogs, the focus is on predicting the shape of the graph. As shown in the picture, I wanted to try to make predictions using a method commonly used in actual trading. In real-world trading, many traders operate in the following way. At a specific point in time when purchasing Bitcoin, they set profit and stop-loss targets. Then, regardless of how the chart evolves in the meantime, they generally ignore it until either target is met. Therefore, I aim to apply this methodology to predict Bitcoin prices and implement a model. Let me introduce the data. There are two main types of data being used. The first type is the 15-minute data of Bitcoin, including the opening price, closing price, highest price, lowest price, and transaction volume. The second type is the same 15-minute data but for the Nasdaq Futures Index. The data spans from July 1st to April 30. This period was selected because I could only find 15-minute Nasdaq Futures Index data up to this point. The test data used is from the most recent month, May. Firstly, for the Bitcoin data, I used the Binance API to extract the necessary information. As for the Nasdaq future data, I extracted the data in Excel format from the TradingView site because the minute-based data wasn't available for free, and paid data is very expensive. Next, let me discuss the pre-processing. The Bitcoin data was clean and well organized, so I did not require much pre-processing. However, there were several issues with the Nasdaq data. For instance, there were missing data points during weekends or holidays when the Nasdaq futures market is closed. There were also some noise, values, and discrepancies in the time format. To solve these issues, I added rows in chronological order for the missing times and standardized all of these values to the close price of the previous period. Empty volume values were treated as zero. Additionally, I standardized the time format. The results are as follows. Next, I'll explain the content of the machine learning code. My prediction code primarily predicts three scenarios: rise, fall, and lateral move. It reads 15-minute data up to a certain point back, determined by a sequence length value. Based on this, it predicts the direction of the next 10 sets of 15-minute data. The criteria are as follows. If a 1% decrease occurs first, it is a fall. If a 1% increase occurs first, it is a rise. If neither occur, it is a lateral move. After this, we train and evaluate how well the model predicts. Based on this, I have created a code to construct a dataset like this. The model used is an lstm considering the characteristic of time series data. 4 different sizes of hidden layers were used for training. The number of layers was fixed at 2 and there were 3 classes. Min-max color was used for normalization, cross-entropy loss, and Adam optimizer were used. The results are as follows. In summary, while a larger sequence length resulted in the smallest loss value, the highest accuracy was achieved when the sequence length was smaller. Similarly, the smaller the hidden size, the more accurate it is. I think it's because 10-15 minute data are too small. There is still a long way to go before it can be practically applied to actual trading. However, achieving an accuracy around 77% without significant adjustments to parameters or batch size, I believe suggests that this approach has meaningful potential. Thank you.